Hello, everyone. We just started the recording of today's workshop, and it's called How to Write a Talk Abstract. This workshop is part of, their not-for-profit organization, Quantum Universal Education, or I guess longer, People Interested in Quantum Universal Education, or PEAK for short. And we decided to have this workshop in preparation for the one-year anniversary of our, of our organization. That's so like a Discord server and website, and supported by a grant from micro grant from the Unitary Fund nonprofit. So basically, I guess we'll start here. So we'll just go through a few steps on how to write a talk abstract, some things to keep in mind, and some examples, and then open it up to questions after. But we'll stop the recording before questions, so you don't have to worry about asking the questions. However, we'd like to prepare a Q&A of whichever questions were asked. So, okay, so we will record the questions so that we can prepare a written Q&A, but we won't post the questions at all, except anonymously and written. And no one's face or video or name will be recorded. Anyway, let's start. So today we'll discuss how to do steps for your talk abstract, such as identifying your audience and capturing their attention, steps to writing an abstract that your audience understands, and probably should have included here what an abstract is. So an abstract is basically about a paragraph long summary of what your talk is about, and it's used to advertise your talk so that when someone reads your talk title and your abstract, they can decide whether they want to listen in on your talk, maybe have some questions in advance even, and get an idea of what to expect from your talk and what kind of prerequisite knowledge your talk is and what target audience your talk is aimed towards. The first part of identifying your audience when you're writing your abstract is that you should provide appropriate background. So it's a good idea to explain all the technical terms, if there are any, in your talk abstract at a level that's suitable for your intended audience familiarity with your topic. So for example, okay, the example's on the next slide, but it's okay if you don't have a full or rigorous explanation for all the technical terms, since the purpose of your talk is to go into more detail. So this is just enough that your audience has the idea of whether or not the level of their understanding might prepare them to understand your talk. So for capturing your audience's attention, you can capture their interest. So you can suggest reasons your topic is important to a broader topic that your audience can connect to. This means that oftentimes your abstract can show, not tell. So if you have an abstract that just states what cleanly what your talk is going to talk about, it also helps to connect the specific topic of your talk to a more broader topic, especially if the audience is a general audience. So for example, the PEAK anniversary celebration, the talk audience, I would say, is quite general, and many of them are students, or us, we're students, who are enthusiastic about learning quantum computing and quantum science. So it's for this event, you can assume that the audience knows about qubits, quantum gates, and quantum circuits. However, if your talk is about, say, a specific type of quantum hardware, for example, you wouldn't be able to assume that the audience knows what that quantum hardware is in advance or how it works. Basically, know your audience. And you can capture your audience's attention by framing what your talk, if it's solving a problem, is doing with respect to the bigger problems that it can help solve and why those problems are important. But we'll see more in this workshop with the examples. Yeah, I guess we'll continue here. So the main part of this workshop is the steps to writing an abstract. These steps are based off this this link that's here that I'll send in chat right now. But this link was intended for more scientific abstracts, and so we boiled it down to just for talk abstracts rather than for research paper abstracts. So for example, a research paper abstract is like something you write after you finished the research paper, writing the research paper, and then you just write like kind of a summary or introduction as the abstract, where it's just very short. But for a talk abstract, it's a bit different because you don't already have like many pages of paper to write the abstract from necessarily. And so also the audience is often different for a talk rather than say something written. Lastly, we also keep in mind that talks don't have to be research talks for the Peak Anniversary celebration. What we're looking for is just any talk about that's related to, say, your journey in quantum, or like a project that you made or some concept that you learned. It doesn't have to be research. It doesn't have to be individual work. For example, you can feel free to talk about stuff you collaborated with others. The idea is to give a chance for people to give a talk and share with the community what you've learned and what excites you related to quantum. And so I would say it's really open, and that's why we're hosting this abstract, because keep in mind that abstracts, and I guess it's a fancy word, but it's not necessarily something that people have had the chance to read before. So I guess we'll go through these steps. The steps I think might seem familiar if the step 0 is the title to your abstract, and this is, I guess, what will first catch your potential audience's eye. And as to writing the abstract, the steps are first the background and motivation. So what is the overarching background for your topic, and why your audience might be interested in it, or why a broader society or some group of people might be important. Some objective that you had, or a open problem that you were trying to solve, your approach to your objective or problem, the highlights of whatever you learned or found, and some aspect of concluding or wrapping up the abstract. So it just doesn't cut off right after like the results. But the conclusion you don't necessarily need in the abstract. As an example, here's just, we highlighted those steps in the previous slide in just an example abstract. I just chose this as an example because this one was short, just 3 sentences. And this was a paper that was accepted to the final round of the ACM student research competition that I wrote there were 12 undergrads worldwide that were accepted. So I think that this was, in retrospect, I think that this could have been a much improved example. There's a lot to improve here, but I think that realizing, like, criticizing my own writing from the past has helped me not only improve on my own writing, but also realize that I had to have written less things that are worse than I could right now in order to come to the point I am at today. So I think this would be a good time to stop for any questions in chat. So the questions in chat wouldn't be visible in the recording. And after that, we would move on towards all we'll dive into the 5 steps. So these 5 steps plus the title that are shown here with more examples. You can talk through them, but if anyone has any questions at this point, feel free to dump them in chat. Also, actually, rather than just showing the slide and having you read, I'll walk through the color coding here of the different steps. So the red part is the title, the 0th step right here. And the first step is the background and motivation. So here it's quite short. It's just showing you that in the most broadly, the category of the type of this talk or this abstract, this was for a paper, but the idea is similar. It was for quantum hardware and algorithms research. The yellow part, the sub 2, is about how there is a need for bridging quantum programming languages and quantum theory and applications and algorithms with the actual hardware, so which is through compilers and quantum computer architecture. The step 3 in here in green is that the approach to this problem was to design, implement, and benchmark quantum compilation and visualization in physics, which is a Python tool for the ZX calculus that my research group works on. Or at the time, it wasn't a research group, but now it is. And apply it to Qiskit, which is the most widely used quantum programming language, as a transpiler pass. And the fourth step, the blue step, is a highlight of the findings where we could reduce the gate counts further than Qiskit's default transpiler. And the purple part, the conclusion, is that we demonstrated with our approach correct circuit optimization for on 1002 qubit randomized benchmarking circuits. Okay, and then I'll answer to a question in chat on, is there a word limitation for abstract writing? In general, no. Well, it depends. It depends on where you're submitting the abstract to. So in addition to the abstract being a way to advertise, say, a paper or a talk, then an audience or person can decide whether or not they want to read the paper or watch the talk. It's also used sometimes to help determine whether the paper or talk is accepted. So, for example, where you're submitting it to may or may not set a word limit on, or some other character limit or something to the abstract. For example, for Peak Anniversary, we set a word limit of less than 250 words, just so that there's some consistency. We don't get like a book for like a whole book instead of just a few sentences. I would say generally for talk abstracts, they will specify about how long of an abstract they might want, or the submission format might indicate that. But if something is like way too long or way too short, the organizers might let you know. So long story short, our limit is maximum 250 words, although we aren't going to count the words. All right, Alberto, do you want to take over, and I can press the transitions and you can talk.
Okay. Yeah, well, in this part, we try to identify or start to build an abstract. Well, how Leah say, we need to identify the title. In this, we need to remark the first or the important thing in the origin of our purpose of our project. In this case, Leah? We need to identify an interesting or the most general describe your topic. In this case, we had 3 examples, all in the quantum topic. The first one is more professional or research, is is quantum circuit that generates morphological operation on binary image. In this case, we need to remark the purpose or the original, or identify the most important thing. In this, the morphological operation, we need to identify what kind of thing we do. In this case, quantum circuits. In the example number 2 is drawing cat comics about the tensor product. In this is more educational resource. We need to remark the importance, and this is not necessary that the material. In this only we need to say the drawing comics. In this cat is because the essential or the big reason or identify or explain the idea is with a cat, and the topic we need to show or try to teach is the tensor product. So we need to connect all the ideas and make sure we need to say uninterested and interested part. And example number 2 is learning quantum computing through MOOCs. In this part, we need to explain in a before part what is the meaning of the MOOCs. Can you remember, Leah, what is the meaning in that part?
Yeah, so this is a reference to Claudia Zendejas Morales post an article on fullstackquantumcomputation.tech, which is about how she learned quantum computing entirely through MOOCs, which are massively open online courses. So that was just really cool to learn from how you can learn from not just your traditional like school or university courses, but that there's options to learn courses entirely online. And this was before Qubit by Qubit, so it was really inspiring to hear from that.
So in this part, in example number 2, the most interesting part is the meaning of the MOOCs. So in the abstract, we need to specify that meaning words and remark or oriented the answer in that word. The next one, Leah. The step number 1, background and motivation. In this, we need to identify the theory, the words that we need to emphasize for our audience. Because if we need consider the audience or the person who read an answer, understand all the topics is the most grand idea we need to do. So we need to remark, well, it's we need to identify the contest, the event, the conference, and in this section is quantum computing. Okay, so we need to identify what is the specific problem. Like an example number 1 is image processing, so we need to identify the specific part in that area. In this case, for like an example, we need to identify what is the mathematical morphology, what is the correlation with the image processing, and what is the meaning in this part, or the useful for this topic. So in that part, we need to, in the case of the comic, we need to identify what is the product tensor. We need to identify the meaning, the concept, explain a general idea, and the third part is identify what is quantum computing. So in that moment, we need to identify what is the open resource. What is open resource, open course? How can prove it to understand that idea, all idea, and we express it in a few sentences, like example number 1.
Yeah, so I'll add here that what this example is from the previous slide, for example. So this example one here was a quantum circuit that generates morphological operations on binary images. That's the talk title. And so here, the reason why one sentence to the abstract needs to define mathematical morphology is because this is a technical term that for a general audience wouldn't know what it means. And so it's really important to define technical terms, even if it's not the most rigorous definition somewhere in the abstract, if the talk is for a general audience, so that they can decide and understand the words. It's true that oftentimes the audience could look up the definitions of these words on their own, but you want to save your audience the trouble so that they can make the decision without having to like open several newer tabs or something, or go down whatever Wikipedia rabbit hole. We'll now continue with the mathematical morphology quantum circuit with applied to binary images examples for the rest of these steps. Just so it's consistent, you can think of just one example, but I'll continue.
Yeah, and if you remember the title, we specify quantum circuit, morphological operation on binary image. So the part of no is about quantum is morphological operation and binary image. So we need to remark this topic in our abstract because that is the combination or the remark part in our project. The next one here. Now, step number 2, the objective or problem addresses. In this, we need to say, well, what is the reason for our project, or what is the necessary we describe this problem, this proposal, this objective. So in this we need to identify it, but in this what we identify, we need to investigate the theory, the general theory about state of the art, identify the previous work that has been done for other persons in a similar way. Yeah. In this example, in example number 1, in this only described in a general way operations in mathematical morphology, but what is the necessary things in this is only for general things. This we can identify for operation, erosion, dilation, opening and closing. If you read other works about image processing with morphological operation, is this popular operation. So it's a good way because we investigate with other works that similar idea, but other parties investigate with what is the similar project in the quantum field. In this case, we need to identify quantum circuits can implement each morphological operator. If not possible or is only theory, we need to clarify that part in our ASTA because we need to remark what is the difference or proposal with the other ones. Remarks or highlights or contribution. Step number 3, your approach. In this, we need to describe the specify the problem or the objective, but we need to remark with respect with the other one, what is the difference in this? What is the contribution, the difference, the mark or project with the other ones? In this, it could be, well, we obtain better results, we okay different things, we okay reduce the number of capacity, temporal space, we identify more funny in video games, we identify or we explain less we explain complex definition with less word or something like that. We need to identify what is the best thing or job. In the example for the morphological operation, our construction is analyzing the two inputs, the input image and the structure element by mapping them to a quantum state using superposition. In this case, we describe the job or all the process we did for explain our project. In this case, we identify, well, in the image processing, we need two inputs. The input will identify a certain specific shapes, and the shape, in this case, we call it a structure element. And what is the different thing? Because we modified it in a quantum state using like superposition. In the step number 4, highlights of the finding. Well, we build certain things. It could be a tutorials, comics, a demo, investigation, experiments, whatever you think. But in this one, what is the best thing or your contribution or your experiment? We need to identify that. So what is the best case? Compare it with the previous work, state of the art, the theory, and identify, compare it with your results. Like in the example of the image processing, we compare it our quantum circuit performance with a classical part. The classical part is what a library uses image processing in a classical way with, well, use it OpenCV. This OpenCV obtained the same process of quantum morphological operation, but we compare the result, the output image, with our proposal. In this case, a quantum circuit.
I think I'll add here that this, as these steps were intended for as some kind of research structure steps for how to write an abstract, and so we held this workshop because we realized that a lot of the workshops or info out there on how to write an abstract is based on these kind of heavily research-oriented steps. But for the equivalent of this step, highlights of the findings that we modified is for these steps is that for something that is a project is, or some other topic, for example, could be what you learned or some project you did, you might not have something that currently exists that you can compare to. For example, if my talk was, I was giving a talk on what I learned and my learning journey, then the highlights of the findings could just be simply, what did I learn? And I guess both philosophically and I guess like in a broader picture, how, how my journey went, and also some more technical details of what is specific things that I learned and can share about.
And then step number 5, the conclusion. In this, okay, we had some results, we had comparisons with the state of the art, we identified the advantage of our proposal, so we need to remark it with a conclusion. In this case, we need to, is the most relevant part on our project. In a research way, we need to identify all of metrics, percentage, measurement, because in a science way, we need to identify with a ponderate or identify some kind of metric. It could be accuracy, performance, something like that, equation. In this example, like this, a quantum processor is compared the classical field with a quantum field. So the conclusion is with a nature with the superposition in the qubits, we can obtain different structure element or structure sub-elements. In the classical part, we only compare it with one element, but in the quantum way, we can compare it, the elements in 2 to the n, the same process with the same size with different values. So in this case, we can obtain a better thing, or yeah, a better thing. In this case is obtain more results, or obtain different ways or different things when as one only process than in the classical part. Well, it's obviously you work with quantum computer, but to prove it, this part is necessary in one project. So if you needed to identify or prove it, you need to design a project and you resume in one answer. That motivation. And one person, when you read all the project, identify the process, and that person only read the that identify what is, if it's correct or is interested for that moment, work with your project or take like a state of the art, like a future reference.
So although you might see abstracts that don't necessarily have a conclusion sentence, sometimes it's useful to have one. And sometimes there might not be some distinction or difference between step 4, which is the highlights of the findings, and step 5, which is conclusion. But you might also have situations where you want to say a bit more about, say, for example, what you want to try next, so future work, or what you would, some broader conclusion that might not be a more specific finding. That, for example, your conclusion could be that sometimes an approach doesn't work, and so the conclusion is that you suspect or have confirmation that this general type of approach might not work for this problem. So yeah, that's all the steps. Thank you all for your attention.